Well, hello and welcome to another session where we will be discussing operators, and it will be in continuation with our previous session that we already have had on operators. So there we actually saw how assignment operator, then negation, complement, increment and decrement operators, how they were working. So in continuation with that as well, we are going to discuss what are basically arithmetic operators and relational and ternary operators in this particular session. So without any further delay, let's jump right in. So let's proceed with the arithmetic operators. So as we can see, we have one more module, operators part 2, and within the source directory, we have again created a package structure org.tbl, and within that, we are having operators demo. So please try to follow along with this package structure. There is no hard and fast rule that you have to do exactly the same way that I have been doing, but this is like a recommended approach at this point. So with that being said, let's proceed. So first of all, what we are going to do is we'll create a main method. And now we will start with our first arithmetic operator. That is addition. So let's say we have two variables. And we have to add these two variables. So how we can do that? We will have one output variable where the sum of these two numbers will be stored. So let's call that output equals to, we use the assignment operator, and then we have num1 plus num2. So here, this is the addition operator. So when you are using this, these two becomes the operand, num1 and num2 becomes the operand. And this is a binary operator because it needs two operands to evaluate the summation. So once the summation is done, the output will be stored in this particular variable on the left hand side. So let's quickly print out the output. And this should be 27. As you can see, the output is 27. Now let's proceed with the next operator, that is the subtraction operator. Here also let's declare two numbers, int num3 equals to 20 and int num4 equals to, let's say, 10, and we will subtract num4 from num3. So we will have another output variable, and we will subtract num4 from num3. And now we will output the result. So it should be ideally 10. So there you go, we have the result 10. So what we basically did here, this is the subtraction operator. This is again a binary operator, and it has again two operands. So from the left hand side operand, it will subtract the value of the right hand side operand, and whatever is the result, it will output it, it will assign it back to the left hand side variable, which is output 2. Now we will move to the multiplication operator. Let me quickly put a space here. So we create two more variables. Int num5 equals to, say, 5. Int num6 equals to, let's say, 6. And int output 3 equals to num5 into num6. So basically what we are doing here is we are multiplying num5 with num6. And here the asterisk character represents the multiplication operator. So after multiplying 5 with 6, we should have an output of 30. We'll see whether that's the case or not. Now let's quickly run the code. So there we go. We are getting 30. So that's all about the multiplication operator. Now we will quickly jump over to division operator. So again, we will have two more variables. Num 7, let's say it's 40. And num 8 is 8. Okay. So we are going to divide 40 by 8. Int output 4 equals to num 7 divided by num 8. So basically we are dividing 40 by 8. So we should be getting 5. Let's quickly check whether that is the same result or not. So we are printing out output 4 and we are getting a 5. So this is how the division operator is represented. It's a front slash. And one more thing that we have to see is these two are integers. Now what about floating point divisions? So floating point divisions is also possible. So let's quickly have an example to demonstrate that as well. So let's say I take a double value this time. Double denum 7 equals to, let's say, 15.5. Double denum 8 equals to, say, 3. Now we will divide 15.5 by 3. So double output 5 equals to denum 7 divided by denum 8. Let's see what is the output. And here we are having a floating point operation. So basically, while dividing two integers, if we have a floating result, let's say I'm dividing 7 by 3. So 7 is a whole number, 3 is a whole number. But once we divide 7 by 3, the result will not be a whole number. So if we are storing that result into an integer, only the integer or the whole number part of that result will get stored. So just to demo that, so let's say I have the same use case. Let's go back to this previous example that we have been seeing here. Instead of 8, I'm going to make it 7. Now let's see what is the output here. So as you can see here, we are getting a 5 now, right? But 7 times 5 is 35, it's not 40. So it is 5 point something which is being truncated, and only the whole number is getting printed in the result and also being stored in the variable output 4. So just keep that in mind. Now moving on to the last arithmetic operator, that is the modulo operator. So basically when we divide two numbers, the remainder is kind of lost, right? We only get the quotient in our result. So what if we want the remainder to also come? So that is exactly what modular operator does. Modular operator divides two numbers and returns us the remainder of that particular operation. So let's quickly check that as well. So I have two numbers, int num x equals to, let's say, 12, int num y, let's say it's 5, now int 6 equals to num x divided modulo, num y, and now we will print out the value of output 6 and let's see what that is. So as you can see, we are getting output of 2. So if you divide 12 by 5, it is not an exact division. So the quotient will be 2 and we will also get a remainder as 2. So in this case, we are getting that remainder. So in order to avoid any confusion, we will increment the value of num x to 3. So now the quotient will be 2, but the remainder will be 3, and in output 6, we will be seeing 3. Let's check that out. And here you go. You get the remainder as 3. So that covers all the arithmetic operators. Next, we will move on to relational operators. So now we will be seeing what relational operators are. So one thing we need to keep in mind is any relational expressions output, the value of those expressions will either be a true or a false. That's basically a Boolean value. So with that in mind, let's quickly jump in. So let's declare two variables, num_p equals to 10 int num_q equals to 12. Now we will use the first relational operator, which is the less than sign. How do we write the less than sign? It's the left chevron character. So we will use if condition here. So how if condition works is, we have to first write the if keyword and then a bracket, and in the bracket we will write an expression whose output will either be a true or a false. If it is true, it executes the immediate block of statements which follows the expression, or else it executes the else block of statements. So if whatever we have written in this bracket evaluates to true, whatever we write within these two brackets will get executed, else whatever is written between these two brackets will get executed. So if I write here num_p is less than num_q, and then we print out num_p is less, and we will print num_p is more. Okay, so which one should get printed? So let's go to this expression. So num_p is less than num_q, so 10 is less than 12, so that is true. So in this case, the first statement will get executed. So quickly let's run this. So we are getting the first statement, num_p is less. So that's all about less than operator. So there is another operator called greater than operator. It is the right chevron sign. So I'll change this less than to greater than. So now what it will check is, if num_p is greater than num_q, then it will print num_p is more, else num_p is less. So what is the present value of num_p? It is 10, num_q 12. So is 10 more than 12? No, right? So it will go to the else block of statement. So what we are going to see in the output is num_p is less. Let's quickly run this. As you can see, num_p is less got printed. So that is about greater than operator. So there is one more variation to this, that is greater than operator with a equal sign and less than operator with a equal sign. So these operators are called greater than equal to and less than equal to operator. We'll see how they work. So using the same variables, let's say I'm changing this to num_p greater than equal to num_q. So is num_p greater than equal to num_q? No, right? So it will go to the else block. So num_p is less, and this will get printed. So we'll quickly run this. As you can see, it is printing num_p is less, because num_p is not greater than num_q and num_p is not equal to num_q as well. So this checks two things, whether the number is greater than or is it equal to the number as well. Okay. So now going to the other one, less than equal to operator. So how do we write? So first the less than sign, then the equal to operator. So is num_p less than or equal to q? Yes. So here we will write num_p is less, and here we will write num_p is more. So basically this condition will evaluate to true because 10 is less than equal to 12. So this line will get printed. So if we quickly run this, we will see num_p is less getting printed. So that covers the less than equal to and greater than equal to operator. We will quickly check what is the equals operator. So how do we actually equate the left hand side and the right hand side, whether they are actually equal to either of them. So let's say I change num_p to 10 and num_q to 10 as well. So now they are equal. Now I'm running a check. So how do we write the equal sign here? It's not a single equal, it is a double equal to operator. So it is going to check, is num_p equal to num_q, which is true because both are 10. So it should print num_p is same as num_q, or else in the else block we will write num_p is not the same as num_q. So which one will get printed here? Num_p is same as num_q, right? Now let me change num_q to 11. Now which block will be printed? Of course, the second one. So let's quickly run that. So num_p is not the same as num_q. Now coming to not equal to operator. How do we write the not equal to operator? We put an exclamation sign and then a equals operator like this, right? So what this is going to check is num_p is not equal to num_q, which is true because 10 is not equal to 11. So here it will print num_p is not same as num_q, and in the else block it will say num_p is same as num_q. Fair enough? So let's quickly run this. So as you can see, it is printing num_p is not the same as num_q. Now let's make both the values equal once again. So I'll change num_q to 10. Now if we run this code, we'll see num_p is same as num_q. So that's the equal operator. Next, we will cover what is a ternary operator. So ternary is kind of similar to what we have discussed in the if statement. So it has an expression. So if the expression evaluates to true, immediate set of statements in this block will be executed. Otherwise, whatever we are writing in the else block will get executed, right? Ternary operator is a bit different. It actually assigns a value to the left hand side. Here, there is no concept of assigning values to the left hand side, but in ternary operator we'll see that is the case. So let me declare int final value equals, I'll open one bracket, and within this bracket we have to write a boolean expression. Boolean expression means the expression once evaluated will give us a boolean value. So let me write num_p is less than or equal to num_q question mark. So this question mark means if this condition is true, then assign 100 to final value, or else assign 120 to the final value. So I am putting two values here separated by a colon. So first we have to write a boolean expression, then a question mark, then what value should be assigned will immediately follow the question mark, and what value should be assigned if this expression is false should follow after the colon. So in this case, num_p and num_q, what are the values? It is 10 and 10. So it is equal to each other. So in this case, 100 will get assigned as the final value. Let's quickly see the content of final value. If we print this out now, it is 100. Now if I change num_q, let's say I make it 11. So now this condition will fail. So if this condition is evaluating to false, then whatever is written on the right side of the colon, that value or that expression will be evaluated, and the value of that expression will get assigned to the final value. So in this case, we will see 120 coming in the final value. So again, let's quickly run this. Okay. So basically what has happened here is num_p is 10 and it is less than equal to. So we just have to use greater than equal to operator. So now it will be 120. So now it is 120. So that kind of covers ternary operators. So this brings us to the end of this session. We have already covered arithmetic, relational and ternary operators. In the next session, we are going to tackle bitwise and logical operators. So if you have liked this session thus far, don't forget to like and subscribe my channel and hit the bell notification icon as well. This motivates me a lot, and hope you are having fun as well in our coding sessions. And with that, we come to the end of this session. Thank you. Thanks for your time. Thanks for watching. Until next time. Bye.